I represent InstaClustr. If you want to contact me later, then alex@instaclustr.com. I'm a system engineer, software developer. I'm working with all different stuff and systems for 15 years. I work for Red Hat, DataStax, now I'm working for InstaClustr. And we at InstaClustr manage a lot of nodes for various customers that need to do a lot of stuff with data. So I'll go over a quick history of databases and how we ended up with NoSQLs and what Cassandra is all about, why would you use it, and I'll explain a bit more on what we do with regards to that. And if I have a connection with that, I may do a walkthrough through our system. Sorry. So let's forget about that one now. So the whole world of the databases started a long time ago when we started working with data. So in the 80s we had standalone computers, mainframes, a lot of sort of one system things where we store data. That continued into approximately the 90s and 2000s, where we got networking, we got a lot of stuff going on, and we started getting network computing in place. And then, in mid-2000s, about 10 bit more years ago, we got to the web, where the data just started flowing without any limits. So basically, what happened in the 90s and 2000s? We ended up in a situation where we could hold more data than one server could hold. If you remember those times, then if you get to a developer and say that something is slow, you don't have enough space, then the developer will say, okay, wait a year, the computer will be faster and stronger and will have more space, it'll be fine. But in the 2001, 2, we sort of got to the limit of the vertical progression of the hardware. It didn't get any faster for one thing. It got much better in horizontal scale. It got more cores in the CPUs. The system got more CPUs in one place. So things became more distributed. But the vendors, the big ones, didn't really manage to handle that. So you would buy more Oracle and that's, of course, going to be costly. And then a few smart guys at a small company called Google decided to do some computer science. So they designed a few technologies that started helping us out. So the big table was one of the first ones. It's a key value store where you hold one key and a lot of stuff on that key. It had a real good benefit of fast and commercial access. And then we got the Nano, which is sort of a framework for storing and analyzing stuff. And eventually we got to NoSQLs. So NoSQLs were born as a result of the basic idea where you have a distributed systems, we have a lot of data you need to crunch, analyze and collect, but you could not do that with the relational models. So what is the basic of NoSQL? It's just a key value store. You have a key and it has a value. But the thing with that value is that it can also be sort of a key value store. So nesting was possible. It created systems that were non-relational, they were distributed, and they were horizontally scalable, which allowed you to add more resources onto the problem to handle that. It had no schema, basically, or not in the sense of relational databases. It was schema-free, in the sense that you could create your schema on the fly. It has an easy replication support. It's, in most cases, just copy some text and you have replication. You have a pretty simple API because you just write data into a hash table or key value store or whatever store you're using. And it's eventually consistent. And eventually that's sort of a functional distributed system. But the main thing was that it supports a huge amount of data. What's huge? Really huge. So the Cassandra started as Facebook. It was an internal project of Facebook. Facebook had a lot of stuff we needed to handle. And At the time, they used MySQL with proprietary and internal extensions, and that didn't really handle the load. So they started a small project inside, started with Java, and they decided to implement a lot of computer science that Google already did at the time. Eventually, Facebook decided to do something else completely, not MySQL and not this Cassandra thing, so they just released it as an open source project, which started developing itself. At some point, the project leader, his name is Jonathan Ellis, he worked at Rackspace at the time, basically decided to just drop Rackspace and open his own company. Run Cassandra database, an open source project. And then Rackspace decided to send a guy who convinced him not to do that and keep working for Rackspace. They ended up opening the DataStax together. So DataStax is a company that does Cassandra. They have basically resources to develop Cassandra as an open source project. And they also released the DDC, which is the DataStax Enterprise version. Basically the best example or explanation of what Cassandra with DataStax is what Linux and Red Hat basically. So it's a very similar model where we have an open source project and there is a corporate entity behind it that does enterprise stuff and support and basically trying to make money out of it. So what is Cassandra? It's a massively scalable partition row store which stores rows of columns, and columns are just data. It's masterless, meaning that there is no single master client model. All the nodes in the cluster are more or less the same. Linear scale performance, that is probably almost linear, but it is quite linear. So the more nodes you add, the more performance you will get out of it, the more storage you will be able to access and store, and the better I/O you will have. It has no single points of failure, and the more nodes in the cluster, the better. And the read-write support is provided across multiple data centers and racks and cloud availability zones, and even between multiple providers if you want to do that. Not recommended. Why would you use one? If you need to support tens of thousands or tens to millions of operations per second, that's a huge data we're talking about. And you need to store and access and analyze petabytes, terabytes, a lot of data. You need fast response time to database operations, and you need to serve without downtime. That's all possible with Cassandra. So what are the benefits to this approach of moving from relational databases to NoSQL and Cassandra, NoSQL and general Cassandra specifically? Is, as we know, linear scalability that allows you to grow a cluster when you need it and as much as you need it. High availability, and it uses commodity hardware. There is no special requirements for the hardware to use and run Cassandra on. So with regards to linear scalability, that's the old study from Netflix. You can see that they had approximately 300 nodes cluster in which they reached 1 million writes per second with replication factor 3. Now replication factor 3, I'll touch that a bit later. It means that every write to the system is replicated 3 times. That's where redundancy and high availability comes from. Netflix revised this benchmark a couple of years ago, and they achieved the same performance with less nodes, and the average access time was 60 milliseconds for 1 million writes a second. That's sustainable. So what's high availability then? Outbrain is a startup in the United States, do a lot of stuff. They have their Cassandra split in between 2 different data centers. So during the Hurricane Sandy, one of them just went offline because the hurricane was coming through. and they were not able to connect to it, but their service stayed up. There was a small window of time where the requests were a bit slow, but then everything was fine. And this is the example from Google, where they have writes of 1 million writes per second on their Google platform. They run this with 300 node cluster, and during this test specifically, 1/3 of the nodes were done. So they reached 1 million writes per second sustainable rate with only 2/3 of the cluster. That's cool. What are the benefits? Benefits are you can run it on any hardware. You can run it on your laptop, in your data center, on Raspberry Pis, on virtual machines. Now, data stacks in the office, they have a cluster built from Raspberry Pis around a big screen, and they have like the off center dashboard that shows the cluster, and you have a button, like physically wired button. You can press the button, and randomly nodes start to just shut them off and restart it. You can see that the cluster is still online. It's very cool project. So how does it all work? I'll go through it, give a technical demo a little bit, but it's not complicated. So Cassandra works as one single database distributed between all the nodes in the cluster. All the nodes are the same. There is no special benefit to one node versus the other, except for the definition of what the seed nodes are. The seed nodes are basically nodes that tell all the other clients and nodes how to integrate. Now, you want more capacity, just add more service. When you add service, the cluster will rebalance itself and handle the load proportionally up to the end. And the more service you have, the more replications you have, the better redundancy service of the cluster. So for example, we have like a basic bunch of data we want to store in the cluster. What Cassandra will do is it will use a primary key that we can choose whatever we like, and in this example we can choose a name, and it will assign a specific node to handle that specific row of data. It does this with hash functions. So it will just calculate some specific hash, and if after that, for instance, node number 8 is responsible for handling that data, that's what's going to happen. The data will be written to node number 8. But if we have the replication number 3, oh, that's 2 actually, it will replicate it to other nodes in the cluster with the clockwise fashion, and the data will be stored multiple times. So now, if one of the nodes 8, 2, 4 goes down, the data is still available. But that's not all. We can have what's called a consistency level. And consistency level is a result of how we work with the database. So I'm writing data to the database, and I want to get an acknowledge from the database that data is there. Now, if I'm asking for a consistency level of 1, that means that just one answer is enough. It means that data is written on one node. It doesn't matter which one. So if I'm writing data to node number 8, I'll just get that. For my purpose, the data is there. But we know that replication should happen at some point, and eventually it will be also on node number 0, node number 2. And then we have consistency level of all. Consistency level of all requires all the replicas to act in writing the data. Of course, this means that we have more reliable data, meaning that data is sitting everywhere in the cluster, but we have a penalty of performance. And then we have the consistency level of quorum, which is a weird formula of splitting it in half and adding 1, and basically means that approximately half of the replicas have written.
More than half.
More than half, yeah. It's more than half. So if you have replica 6, then we can lose 2 nodes to have the data still be available. And then the multi-data center replicas are exactly the same. There is no actual difference in the architecture of the cluster, except for defining which nodes belong to which cluster and which rack. But the actual algorithm that will write data is the same. There's no idea of location or any specifics. So if replicas need to be in this data center and in that data center, we'll just have it. Cassandra will handle all of it. Now, you want more? You want more capacity? You want more performance? You want more throughput? Whatever you need, just add more nodes. Now, what will happen when you add nodes? And just between us, it's not recommended to add 4 nodes to a 4-node cluster. Because what will happen is that the cluster will split the key spaces that nodes are responsible for between the new nodes and the old nodes. So they will need to do some rebalancing. Now, this rebalancing takes some time. And if you have a lot of data and a big database, it's better. There is a few rules of thumb that take into account how much data you have, how much performance you expect from the database, at what rate you should add nodes. But it's not just throwing it out there. If you add a lot of nodes on the system, your performance will probably suffer, and in some circumstances you may have probably not really high database because it needs to move the data. But in general, you just add nodes, let the system relax and rebalance itself, and you have no performance. But the funny thing is that if we follow the previous example of replication factor, then we just increase our cluster by 100%. But the overhead of writing data to other nodes actually got smaller because when we had 4 nodes, we had to write to 3 nodes out of 4. Now, we have 8 nodes, and we need to write to 3 nodes out of 8. So the utilization of the cluster for replicas got lower. And that's why we're getting linear performance, because the more nodes you add, the overhead of replicas will stay the same. So, if this is all good, then internally, what does Cassandra do? So when the write request comes in, it first logs the data in commit log. The commit log is written per node, for every node in the cluster. Then the data is actually written to the mem table, which is sort of a structure in memory similar to memcache. That is kept in memory while there is enough memory to write to. When the memory is filled, then it flashes to disk to a structure called SS table, which is immutable, and it's sort of write only. But with time, you end up with a lot of SS tables, because when you need to update some data or delete data or add new data, you write new SS tables and more SS tables. So what Cassandra does is periodically will run a compaction sequence, which basically is running through all the SST tables and compacting them into one SST table, which means much more efficient work with retention structure. Also, the repair function is required for making sure that all replicas are still replicas of the real stuff. Because sometimes changes happen on the node, and these changes need to propagate to other replicas. So the repair process will handle that, and it will repair all the deviations in replicas, so to speak, that may arise. Now, sometimes this process may impact the performance of a specific node, but the performance of the cluster is inside. Unless all the nodes together start acting, which is improbable. So just to compare Cassandra to other tech, so if we compare that to relational databases, Cassandra scales well beyond the relational databases. For instance, I was talking to some guys before starting the meeting. Netflix has thousands of nodes in one cluster. Apple has tens of thousands of nodes in a cluster. Hulu uses that, eBay uses that. These are really, really, really big applications, and they have really big databases. So Cassandra handles that perfectly. It is much more manageable because the management of the cluster is pretty simple in the sense that you don't really need to do more things because you added more nodes, which is all automatic. The real management that you do for the Cassandra database is behind the configuration. So you need to configure everything properly, and then everything will just happen. And compared to the relational databases and specifically Oracle, for SAM applications, it will be highly cost effective. But Cassandra does not have the analytical query capabilities such as aggregations and joins that relational databases have. And basically, Cassandra in this sense is more of a store for data than an analytics engine. So analytics, compared with Hadoop, what we'll have is that Cassandra was designed as a fast and reliable data store, whereas Hadoop was designed as a data store for batch analytics processing. In general sense, Hadoop is a sort of framework for analytics, whereas Cassandra is a data store. Hadoop has a component, which is an HBase, that's sort of a key value store that can be said that is a competitor of Cassandra. But Cassandra is much faster, much easier to maintain, it's much more flexible, much more configurable, and you could use Hadoop with Cassandra instead of HBase, and in some cases we'll get much better results. Cassandra is Mongo. So first, Mongo is not masterless, it's much more complicated architecture. It's making it harder to manage, but that's what we think. MongoDB does provide some flexibility on querying the data. Their access to data is different and in some cases more flexible. And what about the pitfalls? What the problems of Cassandra are? So one is the CQL versus SQL. So CQL is the Cassandra query language. Cassandra provides two possible ways to talk to the data you have in the database. One is the SQL language, which is similar in syntax to SQL. And the thrift protocol, which allows just direct connection to the data. Now, one big issue with SQL is that people who start working with Cassandra think that, well, SQL, very nice. It looks very similar to SQL. And to compare SQL to SQL is like comparing JavaScript to Java. So it does have a Java word in it, but probably aside from the subjective syntax similarities, there is nothing common between Java and JavaScript. So SQL was intentionally created similar to, so CQL language was intentionally created similar to SQL language to make it easier for developers to work with the data. But one needs to remember that they're not the same. You will not get the same thing from using SQL versus SQL. And you should learn properly what SQL is and how does it differ from SQL to not to fall into that trap. And similarly, NoSQL is not a relational database. So if you do use Cassandra, and if you want to try and recreate your models and data usage and usage patterns from your relational database in Cassandra, you'll be surprised how non-performant that could be. And you'll probably not be using Cassandra at its full potential. And really, really, really important thing is to design your schema and your usage model to match your data and usage patterns. Because that will allow you to really, really get the benefits from Cassandra with 1 million writes per second and 6 millisecond times. Now, does that mean that Cassandra is the answer for your problems? I don't know. I can't tell, because I wouldn't know what the characteristics of the data are. I wouldn't know what your usage patterns are. But that's what we do in InstaClustr. So InstaClustr is a company. We're a startup company based in Canberra. We have an extensive experience in designing, deploying, and managing critical infrastructure for our customers that require really big scale. We host and manage Apache Cassandra, DataStax Cassandra, and Apache Spark for the analytics. We do work with other complementary technologies, such as Kafka and Spark Stream and like that. We really develop a range of related consulting and support for the Cassandra and data analysis and data modeling. Our tech is we run on AWS, we run on Azure, we run in IBM software, Heroku, and other platforms as required. We work with other platforms to support them. We run CoreOS as our main operating system on all platforms. CoreOS is a minimalistic operating system that is really good for running Docker containers, which we do. And Docker containers are really good for creating them once and running them everywhere in a similar fashion. So that's what we do and that's what we are. Some customers' feedback that we have. Fling is a product of a company called Uni that is sort of a social network that allows people to share their thoughts, pictures, videos, and whatever with 50 random people. Just create something, send it to 50 random people. And it's sort of fun, I guess. We help them to build their model, their database, and we host it for them. Math Pathway is another company that created an educational platform where the platform analyzes each student's abilities and level and creates a learning program that's specific to user and his abilities and his level of progress, and that program basically follows the student. They have sort of a test periodically, and the program can suggest more stuff. And we help them to build their data store and data structure and schema and architecture, and we do most of their services as well. Do you want to see how we do this? Like how to create a cluster?
Yeah.
On our dashboard? Alright, so if this works, then what we do? Okay. Let's see how that works. Alright, so this is just the website. You can find here products, services, we have an excellent support. You'll find customers' testimonials, that's not like normal website do. Let's try to create a cluster. Do you see that alright? Okay. So, just before I do this, when I started working for DataStax, I had to pass the exam to enter the company. So for the exam, they had a demo on their website, which they basically asked to install on your laptop and run. The problem was that there was a bug in the demo, so it didn't work. And it took me about a week basically to try and create a cluster on my laptop and make it work and understand that it doesn't work and it has a bug and all that. Now,
was that the test?
Well, probably because that's what I sent them. I said, like, you have a bug in the demo, and eventually got it, so probably that was fine. So we'll call these big Adelaide. So you can see here that we can choose Apache, Cassandra, or DataStax Enterprise. The difference is more than price is DataStax Enterprise is similar to what Red Hat does with Linux, as I said before. There are more security patches, there are different configuration default values, and you get the enterprise support from DataStax. We can also add Spark, but we won't do that at the moment. We can choose one of the three providers here. Region, we'll take use East, we'll take few small nodes, and then we have network definitions. I'll add my node to be able to connect to the cluster later. And now, well, it would be fun to wait and watch, but that will take about 15 minutes. So, questions?
So this is, so purchasing the nodes in AWS and distributing your Docker images to them, and then configuring them, and so it's doing the whole thing from scratch.
Yeah, so what you see now is like, you see that even the public address is not available, because the hardware doesn't exist at the moment. It will be there in about 5 minutes. Well, I think that's how USS works.
Okay.
If you take like Asia Pacific, that'll take probably 14 minutes. So.
Oh.
Well, that depends on the data standards that the kids set down there. Specific in the cloud. Not something like that. Yeah.
Have you used this on Apache Mesos?
Sorry?
Have you used this on Apache Mesos?
No, we didn't. Mainly because we didn't have anyone wanting to do that. But architecturally, we probably can do that. Cool. Yeah.
How does the client know which node to query?
That's the IPs you'll see over there. So you see we already have the nodes. And that's their IPs.
The client gets
But how does
the client connects to a set of nodes, which are called seed nodes. So in our case, it will be all three. In a database where you have thousands, you'll have probably a few sets of those. It's like not 3 nodes that will have all incoming traffic, but a few groups of tens probably.
So, do you connect to a single IP address, or do you connect to IP pool?
Well, that depends on how you want to do this. If you're using libraries like Java, Python, Ruby, C#, whatever, you have to provide the endpoints to the connection. I'll show you later. When this will finish, I can show you later. We have the code examples of the connection specifics. So what you can do there is you provide a list of endpoints. Now you can provide just one. It will discover everything else automatically. So you can provide all 3. And then it will try to connect to the first one. If it doesn't succeed, it goes to the second one. If it doesn't work, it goes to the third one.
So each seed knows the full configuration of the cluster?
Yeah. Because all the nodes know seed nodes. And seed nodes know themselves. So eventually, all the nodes via the protocol that tells the nodes to connect between them and discover seeds and nodes, basically gossip, they will just connect, and the seeds will know about every node in cluster.
there is this metadata, where will be this metadata information? In which node the metadata will be there?
You wouldn't know. That depends on the hashing function that basically runs through your data and decides which node will hold it. The specific node in the cluster will hold a slice of potential hash keys, but that slice is constant until the cluster changes in size. So if you have like 3 clusters at the moment, the whole range of possible hash results is split to 3. Okay, so your request will end up on one of the 3, depending on what comes in and how hash function works. And the hash function that Cassandra works by default is something I think similar to MD5, which is 120 plus space. Yeah.
Where did you choose the size of the node? I see it's T2 small.
Yeah, it's a list.
That was up there somewhere?
Yeah, in the list.
Yeah.
Well,
Okay.
small is just the smallest one that can physically run Cassandra.
Okay.
Anything smaller than that, you'll not get good results.
So related, is this, when you configure your account, do you put in your own AWS credentials or is it
No, that's ours.
InstaClustr?
That's ours. Basically, you don't really care where it runs. So why is it good for our customers? Because customers can concentrate on their application, on their thing that they want to do, and less about managing the database. They just come to us, they say, we need this problem solved. We help them to solve that problem with Cassandra, and we run Cassandra for them, and we'll give them the endpoints. They just type the endpoints in their app, and everything works.
Some people like to have control over the machine
Well,
that's running them.
That's correct, but so that control, it may come from 2 different perspectives. One is the speed of the data transfer, right? So if your application runs on Azure, you wouldn't really run on Amazon, right? And you would run on Amazon if your app is on Amazon. But more than that, we can create the VPC connection to your stuff, so that Amazon basically creates a sort of a local connection between data networks. So there will be sort of native speed between the data centers. The second possible reason why we would need that is, company information, proprietary, and all that stuff. But it's proprietary. I mean, nobody can see it besides you.
That was less than 15 minutes, wasn't it? So we have 2 nodes running.
Yeah, that's
Yeah.
even pretty cool. What next I will try to do, no, I won't be able to do this.
You have to wait for the third.
No, my phone broke, so I don't have the authenticator to connect to the system and create data. But I'll show you in a second other things that we have on the dashboard. Sure.
You mentioned the weak part was the lack of analytical support through
Yeah.
Cassandra. How would you recommend you do the analysis then on the data you're
Right. So there are a few possible ways to do that. Hadoop is one. If you talk with the Cassandra community, you'll see that people prefer Spark. Now, Spark and Hadoop are a bit different, but they have like overlapping features. For analytical processing, Spark in some cases will be much better. This will have super fast engine, it is much more flexible, and well, it's just much faster. And Hadoop is, just run Hadoop over the Cassandra. And another thing is that Cassandra community has a driver for Spark, which makes the integration much more smooth and fast.
Probably got about 2 minutes left, Alex. Maybe last.
Excellent. So, a few things. I was asking about the code. So, when we go to the settings, you could adjust the firewall settings over here. So, at the moment, only my computer can connect to that DataStax cluster, to that Cassandra cluster. No other client will be able to, because the firewalls will not allow that. And then the connection info you'll have here all the details about the cluster. So the endpoints, the public ones, the private ones. You'll have Java sample code, Python sample code, Ruby sample code. Cassandra has C#, I think C, C++, PHP, a few others. And then you could also add nodes or data centers to this cluster, which will be rebalanced and all that.
Question.
Yeah.
If you add a data center, do you need to add it? Do the data centers need to look the same? So
Not
3 nodes
well,
one, you have to have
it'll
3
be
nodes
better,
down.
but not necessarily. But when you add the data center, it will show you the configuration of nodes you want to do.
Can you show us some code, how to actually write, like, I mean, except for those examples?
You mean this?
Yeah, or do you have any other code which actually makes connections with the, like, I mean, any sort of demo examples of how it works?
Well, I don't have it here, but we have a couple of blog posts on Heroku.
Okay.
And, well, on Heroku we have it for Java, Python, and Ruby. So if you go to Heroku and you want to add InstaClustr, you'll see the code examples. They're like full code. You can just take it and run. This is just a, a specific code for connection. That's about it. Oh, questions? Yeah.
On what basis do you select the data center, Amazon Web Service or Azure or something else?
That's a customer selection.
But shouldn't you be suggesting them the best thing?
Well, if they want our advice, then yes, of course. But it depends on what customer wants. It's like if my application is in AWS, I wouldn't run Cassandra in Azure.
Okay.
Because the network.
Okay, so depending on the customer.
Yeah.
Go ahead. Last question.
Last question.
Price.
Last two.
Price. How much is this?
Price, sure. So it's
$60 per month. I saw
yeah,
it when you created it.
T2 is $60 per month per the whole cluster. I think that one node is $20.
Yeah.
How much was it?
Do you need 3 nodes at a minimum, or you can only have 1?
Well,
I mean, to test it out, basically.
you could run it on one node, of course, and you won't get any benefits of it. But if you just want to learn in Cassandra what it is and how to work with it, there's no hard limit on how much or how less you want to. And the last one?
I have a question about, you were talking about the schema and how it's supposed to relate to the query.
Yeah.
So can you give a concrete example of maybe how you'd structure the schema to match the queries and the data that you're storing? And
That's really
maybe a quick example
specific to the examples that you want to do, because I mean it's basically a JSON object in the database, like say native in the database. So you want a few points, like you don't want your rows to be too small, you don't want them to be too big. How much exactly? Like if you say that 1 million entries in a row is really too much, and 10,000 is not even changing the pulse of the database, then how much is okay? 1,000, 100,000, 200,000, 300? I don't know. That depends on what you want to do. So that depends on how much you want to store, how much you want to keep, and how much you do want to analyze.